I'm Deborah Seahorn. I'm the State Department representative on the CSTA Board of Directors, and it's my pleasure to introduce you to your speakers who are also on the Board of Directors. And the first one is Karen Lang. Karen has worked as a computer programmer for 12 years and then switched to teaching. And she's taught math, computer applications, and programming to high school students in New Hampshire, all the New England states. And she's also served as a technology coordinator in Venezuela and Hungary. And she's currently teaching computer science at the Massachusetts Academy of Math and Science in Worcester, Mass. This is her second year on the board, and it's been a pleasure to serve with her. Our other representative speaking today is Margot Phillipps. Margot. And Margot is our international representative. She has a BS in math and philosophy, and she worked for 8 years as an analyst programmer and then switched over to teaching. And she has taught programming in databases for 15 years and has also taught high school math and programming. You can read the whole bios if you're interested. And she has worked with the International Olympiad and is the executive director of the Programming Challenge for Girls. So prepare to learn a lot about programming contests.
Okay, thank you, Deborah. All right, so I'm going to start off with just talking about what we're going to hope to cover in the next hour. So the first thing we're going to talk about is the different contests that we know about that are available. Also, there's talk about whether or not programming contests are worthwhile or a good thing or a bad thing. So we're going to talk about the pros and cons. And then hopefully at the end, if all goes well, we're going to talk about how to design your own competition using downloadable software. All right, so to start off with the different types of contests that are available, we divided into written contests, off-site contests, online, and then your own. So for the written contests, the ones that we are aware of are the Australian Informatics Olympiad, and Margot will talk more about that. She's familiar with that. The American Computer Science League. Off-site, team-based competitions such as the New Zealand Programming Contest, the Programming Contest for Girls, also in New Zealand, and then college and university-sponsored contests around the states. Online contests such as the Australian Computer Programming Competition, the IPSC, the Internet Problem Solving Contest, the USACO contest, which is practical, also online, but it's an individual contest for students. Then the Elite Contest, the IOI, International Olympiad in Informatics, the ACM, International Collegiate Programming Contest, and then as well, there's also practical in-class contests that you can run yourself. All right, Margot?
Okay, so in Australia and New Zealand, we are in a similar state to the US in terms of computing in high schools. And Australia is probably light years ahead of New Zealand in terms of some things. And one of the things that they have done is run a written contest for years, and they export it. So New Zealand schools are now invited to join in with this. And the problems are written by people who are involved in the Australian leadership for the Informatics Olympiad. So they're often really, really well thought out problems to do with, initially at the junior level, even an intuitive feel for something that's an algorithm that you will learn later. So there's an example of a problem where you've got a braided river system, factories on the river, you know that there is pollution happening, but you don't know what factory it is that's doing the pollution. How many testing stations do you need to put? What's the minimum number that you could put to find which factory it is that's doing the polluting? The problems are all of that nature. There are about 12 They have an hour and a half to answer these questions. They're all multi-choice. We package it all up, send it to Australia, and back comes, how many you got right and percentiles. And one of the things that has happened in New Zealand education and somewhat in Australian, and I suspect in American, is that we don't rank children anymore. So we don't say you're the top of the class in whatever. We don't. Our external exams in the last 3 years of high school don't give you a mark. You either achieve, you get merit, or you get excellence. These sorts of competitions, particularly in maths, because the same organisation that runs this also runs maths, they are phenomenally popular because, funnily enough, the kids and the parents actually quite like knowing where they are. These competitions are very popular because they rank children, and we have taken all of that out of our school system. And this is something that you just sign up to as an extra, right? So you don't have to do this, but people actually seem to really like it. And is it down button?
Right.
The right one. Okay, thank you. So that's a written contest. The New Zealand programming contest is organised slightly differently, and it was originally designed only for tertiary, and about 5 years ago they built in a high school division, and it's through that I actually find students for the Olympiad eventually. So this is all day on a Saturday at numerous sites around the country, and originally it was 10, 30 and 100-point problems, so they were graded in difficulty, and there was about 4 of each. And when they built in the high school, they built in 3-point problems. And so we would aim for high school students to be able to solve any of the 3-point problems and maybe a 10-point problem. And I think the first year it ran, one of the high school teams got a 100-point problem out and embarrassed a lot of the tertiaries. So, and it's a fun event. It runs all day at a university. There is pizza at the end of it. When I've taken high school teams along myself, the first time I did it with trepidation because it's 5 hours of pure concentration, and no high school kid that I knew had concentrated more than about 30 minutes at a time, but they seem to just lap it up. And I've been doing it for 4 or 5 years now, and students who I originally took are still coming to it. They're not studying computer science necessarily at university, but they still come and do this contest because they loved it so much. So it was, I found it a real motivator. And it's nice because I get to keep in touch with them. I write, along with the contest director, the 3 and the 10-point problems, and I'm slightly subversive, so I always write one that features women or girls. So I changed the flavour of the problems, and they're always some kind of story, and you just have to read through the story and figure out what it is that you're trying to do. So this one's slightly famous because the top New Zealand team, not only in this contest but in the South Pacific region for the ACM, and that eventually ended up 11th in the world, when they were doing the problems, this was the only feminine one, and it was only 10 points, and they were solving all the 100 points. This one was left till the very, very end. And I thought, I know it's only a sample size of one contest, but it told me a lot about how people read problems and what they think about them. And even their coach was saying towards the end of the contest, when they hadn't solved this one, gosh, this must be a really difficult problem. And I said, no, it's only half a page of code, but it's about a girl problem, not a boy problem, or a neutral problem. So that one's obviously just a binary search. And all of the problems are phrased like that. So there's a story, there's sample input, sample output, and they can obviously run and test that before they submit. And they submit to the judges using PC Squared software, which is what's used for the ACM, and which Karen and I are going to cross our fingers we can demonstrate to you towards the end of this presentation. There's a lot of background to say that we don't involve girls well in programming, and New Zealand is just starting to get computer science and programming as a formal subject at the last 3 years of high school. So this is aimed at the year before that, and it's right at the end of the academic year for us. We run from January through to, February through to November, December. And so I hold this in November, and it's based on the idea that girls are unlikely to enter something on their own. Some will, but we'll get more if we say, bring a friend. And there's usually at least one of the girls is motivated, and often the winners, they're both highly motivated. We've done it for 2 years. First year, the girls had almost no exposure to anything like this before. Last year, what we found was that schools were returning and their teachers were trying to teach them so they could win. And so we're probably going to have to change the way in which we run it in the future, just to cater for the fact that some girls will have had quite a lot of exposure and some will have none. But effectively what we do is we get them in for the whole day, and we try and get a tertiary to support us and to provide lunch and to provide the room and to provide all the gophers. And the teacher comes with their 2 teams of 2 maximum, sits through a tutorial on Alice. They have some practice at Alice, and what we make sure is that the tutorial actually is going to cover the skills that they will need in the challenge. They go off and have lunch. Then we've got captive teachers, so we do some PD with them, and the girls go off and sit a challenge, and they just do similar types of problems to, theoretically similar, obviously different world, etc. One of the things that we do is, that Alice is really, really rich in terms of characters and scenes and all that sort of thing. We limit it, right? So we cut down their world and we cut down their characters, and there's very little that they can do, so that they're actually focused on producing code rather than, oh, that one looks prettier than that one. We went for teams of 2 because we thought 2 is support, 3 is dysfunctional when it's teenage girls. So it seems to have worked. We got some medals made, we've run it at different sites. Last year we got it across about 5 sites, and at each site the cut-off mark to be gold, silver, bronze would change, and we don't really care about that. We just care about getting the girls involved, and they do seem to actually really enjoy it. Whether that will trickle through into actually taking the more serious CS courses in the next year, I'm not sure. The ACPC, Australian Computer Programming Contest, is an online contest run from Queensland. It would suit anyone anywhere in the world because it runs over about a 10-day period. You register your school, you register your students, and you can run it anywhere in that 10-day time frame. The students that I've had who have done that in the New Zealand Programming Contest prefer the New Zealand Programming Contest because they like going off, doing this specially. This is in class. You have to, it's an hour and a half, so you have to obviously get permission to be relieved from going to the next class because it's longer than a period for us. But they found that the whole atmosphere was kind of lacking because it's still in school. So good practice, perhaps not as attractive to the students as going off-site for the day. Karen, you're going to talk about USACO.
So the USACO is another online contest. Rob Kolstad is the person that's organized and runs it, and this is where he pulls the U.S. team for the Olympiad, the International Olympiad. It's online. There are 6 contests throughout the year, and what you do is you as a teacher would sign up, and then your students would sign up and put you as the teacher. So it's entirely individual, and what it is they'll set aside I think it's a period of 2 or 3 days, or 1 day, but the students have 2 to 3 hours to complete a set of problems. The nice thing about this is they have training pages, So the students can sign up, and it's just a series of simple problems that they would go through to learn to program in Java or C++ in preparation for the contest. So if they do well enough on one contest, then they're allowed to go on to, say, the silver or the bronze competition, and eventually, potentially, to the U.S. Olympiad team. The American Computer Science League contest has 4 contests per year. It's not online. It would be similar to, I think, the ACPC. So there are 2 types. The first one is called, or they have different divisions. The first is the classroom division, and it's a paper and pencil test. The kids have 50 minutes to complete the questions. What I do is I use it as part of my curriculum. A lot of the topics have to do with discrete math and related things. So it's a nice kind of addition to my curriculum instead of just pure programming. And so I have my entire class take the test. And then what you do is you send in your top 5 scores. So you have everyone take it. So if you have hopefully 5 kids that get a perfect score, you're good. In addition to that, they also have a programming contest. It's at the same time. And there's 2 parts to that. First is a programming problem. The kids have 72 hours to complete it. What I do is I'll hand it out on Friday at noon to my students, and then they have to submit it to me by Monday at noon. But you could do it at any point. So you give them 72 hours. They're not supposed to talk to each other about it. It's supposed to be individual. And what they do is they submit their code and/or an executable to you as the teacher, and then the teacher has the test data. So what I do is I just run it, and they're allowed to use any language that they want, as long as you as a teacher are able to compile it or run it. So this is nice for me because I teach my kids in Scheme, and so they're not able to do a lot of the other contests, but they can potentially do this one. So those students would complete the programming problem. In addition, they also have to do a shorter quiz, a 5-question quiz, but that's very similar to the classroom quiz. So they're the same topic, so I would have already covered that in class. And like the classroom contest, you would only have the students, or you'd take your top. In my case, I'm on a 3-person division, so you take your top 3 scores. And also for this one, I find that it's difficult to get the kid. They're kind of pumped up for the first one, which is in December. As the year progresses and the springtime rolls around, it's harder and harder to get the kids, because this one's optional, to get the kids to participate. So usually the first one, I'll have 6 or 8 kids that will try the problem. By the end, I'm scrambling to get 3 kids to actually finish the problem off. And then at the end, they have the scores online throughout the year, and then in May, the top teams are invited to an all-star contest, and that's in a different place every time. Usually it's some high school somewhere in the United States. It's an international contest. Most of the teams are from the US, but there are some also international teams. This is an example of the written problems for the classroom division. So they do Boolean algebra, and then they do a lot with converting between different computer number systems. So it's a nice addition to the curriculum. This is an example of the programming problem. So, and this is towards the end of the year. So by then, hopefully you've covered this in class. So we did binary search trees. So hopefully you can fold in with your curriculum as well. So they have to construct a tree, do depths and internal and external path lengths. The other type of contests that I participate in a lot are university-sponsored contests. And these you just kind of have to seek out, and it's word of mouth. But there are many colleges and universities that will run high school contests. It's usually either a half-day or a full-day event. So It's a bonus for the kids usually because they get out of class for the day. Usually the teams are either 3 or 4. It's a team competition, so they get one computer for the team. So usually one person's assigned to be the typist, usually the one that can type the fastest and also debug errors quickly, where the other ones are off kind of writing out code or pseudocode on paper and pencil. There's no internet access allowed, supposedly, but I've had my students report back that the team next to them was on the internet getting the answers. So usually they limit it to Java, C++. Occasionally I've been to contests where they have Visual Basic as well, but generally it's Java and C++. The number of programming problems ranges from 8 to 12. They're given X amount of time, so it could be 3 hours, 4 hours, and they can just solve as many problems as they can as fast as they can. And then the team who solves the most problem in the fastest amount of time wins. Depending upon the university, sometimes they'll penalize them for an incorrect submission, so they have to be a little more careful about, let me just change something and just keep submitting. So, this one can be interesting, and what Margot was mentioning. The kids love it because they can be ranked as, we got first prize, second prize, third prize. It's a competition, and the kids really just do love to go to these and eat it up. This is an example from a problem at WPI, which is a contest that we go to every year. So basically take the input and then do transfer it so it's to the right and then down. Okay, elite.
So the USACO contest that runs here is the way that the American team gets selected for the Informatics Olympiad. Because we don't have the manpower to produce an Olympiad-style contest in New Zealand, we actually use the New Zealand Programming Contest as a way of identifying students. And the problem that comes with that is that the New Zealand Programming Contest is 1 computer teams of 3. And so every high school student who enters, I contact them and I say, are you interested in taking this further? And so far I've been lucky, and only the really, really keen person in the team has contacted me. But there is the potential, obviously, for people to be relatively weak, the weak member of the team. The problems with teams, I think, is that, as Karen said, you'll get somebody who is designated the typist and is not contributing the brain power. So one of the things that I try to do and encourage in any programming contest is that you actually, if it's a team one, to actually divide the problems up. And that's your problem. But you don't just concentrate on your problem, you will be assigned another problem for which you develop the test data, right, so that you're testing the other person's program effectively. So there are lots of strategies around team-based programming to make you a more effective team. I know the Netherlands, for the Olympiad, in their national competition leading up to selecting their team, that there was some advantage given to any teams that contained a girl, and they dropped that after about 2 years, I think, because the girl was the typist. So the Olympiad is held approximately every August. I think when it was held in South Africa in the Southern Hemisphere, it was in December, because it's generally a summer event, and it's almost always in the Northern Hemisphere, but it has altered from time to time. And the national organisations kind of work on their year-long cycle of August to August, with the culmination being that you attend the Olympiad. Each country is allowed to put in, they call it a team, but in fact everybody competes as an individual. The algorithm is more or less, the bottom half, thank you very much for coming. The top half will go home with a medal. of that top half. The lower half of those will get bronze, and then there's the top quarter, if you like, is split into a third and 2/3. So it's a 12th will get gold and a 6th will get a bronze medal. The countries that excel tend to be countries where computer science in high schools has been valued for a long time, or where there is a huge amount of resource given into it because the country's pride is at stake. So China, Poland, even a place like Lithuania, where they've had an advocate for CS in their ministry for a long time, do extremely well. The US also does extremely well because Rob Kolstad, who runs the Seiko site, is highly motivated and puts a huge amount of effort into training. He's also, he's not just US-centric. He helped train, I think it was the Syrian, but I might be wrong, but one of an Arab nations team last year, and I noticed they were up on the stage quite a lot as well. So he's, he offers it to anyone around the world who's interested. After those 6 contests that Karen talked about, he puts forward further contests for the American squad, if you like, and every now and again he invites extra people into that, and I know the Australians have benefited from that. So there's been a relationship between Australia and the States. That's us last year in Bulgaria, and the competition lasts for a week, or they call it the competition for a week. There are 2 contest days. There are 4 problems that they must work on each day. Each is scored out of 100 on different test cases. Effectively, you can't get 100 unless you can see the most efficient solution to a problem, and the problems are usually extremely difficult and will involve you putting together creatively a number of well-known algorithms. So you're training these students at sort of 2nd, 3rd year university algorithms stage. Okay, so am I doing arguments against, or were you? I can do it. Okay, so if we roll back a little bit, why are Karen and I doing this? Well, I don't know if any of you read it, but did anyone see Karen's blog post about 6 months ago about contests? So Karen wrote how she had run a contest in school and how much the kids loved it. And I went, there's a woman after my own heart. So I said, Karen, let's do this thing on programming contests because we think they're hugely motivational. But the arguments that you will hear against it are that it fosters poor coding. And in fact, I have had this from university lecturers, even ones who are supporting the contest in the sense that they're prepared to host it in the university, but they say, it's, and it's not thinking about the user, and there's all these other things that are wrong with it. That they're not well designed, that the programs won't be well designed, that they're obviously not documented, certainly not extensible because they're only going to solve the problem that has been put in front of them. If you're pushed for time, you're not going to write it in such a way that you can extend it, obviously. That they're not real world problems. They are certainly, the lower end problems are artificially constrained. I would admit to that. When designing the 3 and the 10 point problems for the New Zealand programming contest, you realise that you think, here's a great idea, but then you have to put constraints around it. Only available to a few students, and certainly the language thing that Karen mentioned does get in the way. So the Olympiad has this official languages, C, C++, and Pascal. And I knew an Australian boy who insisted on writing everything in Pascal, but he was so fast. He still got his gold medal. If you use C and didn't use the standard template library of C++, you'd be shooting yourself in the foot. So effectively it's C++. And there are a lot of arguments about using C as a teaching language in schools, for example. I have always taught in C in high schools, and I haven't found it a problem, but I do it by introducing it in the way that there's all this rubbish you have to put at the start of your program. Just trust me, just put it there, and we'll explain it later. But this is what we're really doing. And then when you get into arrays and you've got to count from 0 and not from 1, well, we can get around that. So, eventually they kind of just grow into it. And so I haven't found that a great impediment. And people ask me, like even the other day, I was questioned, why are you teaching C? Why are you advocating C? And I said, because I want to take people to the Olympiad. Right, so that's kind of my passion, is to, get New Zealand involved in that, because until 3 or 4 years ago we weren't. Right, so, and the how we got invited or involved, I suppose, was that people said, you're supposedly a first world country. This Olympiad has been running for 20 years. Where are you? So that was it. The typical image of somebody who competes in contests is probably those people that we saw downstairs this morning. So those Google interns that started today, so they all had their ICPC shirts on. And so they look like, this typical stereotype. And certainly when you're looking at the elite end of it, at the IOI, very, very few women, or girls, should I say. The first one that I went to, I think there was one. And she got a bronze medal, and the clapping went on for about 30 minutes, which I thought was just a little extreme. But the girls tend not to get into the Olympiad teams. Over the few years that I've been going, I've seen more and more, which is, very encouraging. But a lot of the contests are dominated by male. That may be to do with the kind of competitive difference as well. I'm still going? I'm still going. Okay. So software engineering practices, and I mentioned those before, that are not put into place during your coding in a contest. So does it matter? Well, I surveyed just about everybody that I've ever had anything to do with in terms of programming contests. So almost ex-students and people who are involved in the Olympiad with me and so on. And I said to them, this is what I'm doing. I want to go and say how wonderful contests are and how motivational they are. What are the negatives? And actually they came up with some of the negatives because they've been told them. But they all said, you're right, there are some things which are not practiced in a programming contest. Does it matter? Answer clearly from them, no. And in fact, they thought that they had learned some really, really good habits from getting heavily involved in programming contests. And to say that they're not designed is actually wrong, because once you get into the harder problems, they have to be designed. They might not be designed in such a way that you'd want to hand it in and get it marked, but they will have been thought out and designed. So Karen's going to do 4.
So obviously we both feel that that contests are indeed worthwhile. The first and foremost is that what they're doing is they're going and solving a problem, which is what we intend for them to do in class. So when they're either at a contest or at home working on an online contest, they're problem solving. They have to, a lot of times they have to implement either, known algorithms or, come up with their own, so they're having to work with algorithms. There's definitely the need to be able to work under pressure. Almost always they're timed, and there's several problems that they have to try to accomplish in a limited amount of time, so there's the time pressure. They have to test, especially in the online ones that you submitted, and that's it. It's either right or wrong. I know the ACSL, the same thing, the programming problem. When I get the test data, I'm only allowed to run it once. So they have to really test it fully before they submit it. The on-site ones, like I said, sometimes they penalize you if you submit something incorrectly. So they have to really fully test it. It's extremely motivational. The kids just eat it up. They love going to them. Almost always, at least the on-site ones are team-based, so there's the team-building aspect. it improves their core programming skills. So it's just another way where they're getting, a day or several days of practice on their programming. It's good PR. It's good PR for, I know the universities that run it. It's good PR for them to have 100 kids come in for the day and see what's going on in their computer science department. It's good for the kids. They get to stand up at the meeting at Monday morning meeting at school and say how they did at the programming contest, and it's just fun. All right, hopefully this will work. This is a video I took of on a Saturday morning on the way to a programming contest with my students in March. All right, Nick. So why'd you get up on a Saturday morning to do this?
Because I like programming. I've been taking classes since junior year or sophomore year, and it's just something fun I like to do.
Now, are you thinking of majoring in CS?
Possibly.
Possibly. What are your other possibilities?
Math.
Math. Okay.
Well, I love programming, and I went to the last 2 programming competitions.
Okay. Why are you here?
Sometimes I wonder that myself.
Why are you giving up a Saturday for this?
I don't know. It's fun to program.
It's a good experience.
Really, it's a lot of fun, and I enjoy team programming. It's even more fun than doing stuff individually, and the working under pressure is also enjoyable.
And what do you think about the kind of the format, the kind of the team, 4 people, 1 computer, that whole thing?
It works. Like, one person's on the computer, and all the rest are like writing out the code and just rotate who's working on the computer.
And you like the team aspect of it?
Definitely.
How does this compare to like a math meet?
This one's not quite as intense. You get much longer time to do problems.
But it's 3 hours, so it's not really that much pressure in the beginning. But then when you get down to 20 minutes, you have 3 problems you're simultaneously submitting, working on, trying to get your other team members to check. It's a lot of fun.
I found the submission program kind of frustrating, but it's still fun to work on the problem.
But so despite that, though, it's still worth going and
Yeah.
just having fun. Was it stressful? Did you?
No, it was more relaxing kind of, but yeah,
Yeah,
teamwork.
fun.
I enjoy this because I love to program and it's fun.
So again, it was a Saturday morning, so they weren't too philosophical to get them to say something. But a couple of things to notice from this is very stereotypical. I had all boys, all white boys. So it's there is that aspect that you're limited, and it's not necessarily adding any equity. The other thing I wanted to mention was that the kid that talked about how he loved working in the teams and everything, he just graduated, but when he came in as a junior, he is really extremely quiet, wouldn't talk to anyone, and now he's the one advocating for working on teams. Okay, so again, the problem-solving aspect, and these are, I guess, your quotes from your students, right? So, it's your challenge to solve a particular problem. You have to understand algorithms to be able to solve the problems, and then, working quickly under pressure, trying to fix bugs. The other big thing with the time problem, when you're given a set of problems, generally the problems go from pretty easy to pretty difficult. So figuring out which are the ones that you're going to solve first and quickly, because it's cumulative. So if you try to tackle a hard problem first, that's the wrong way to do it. You got to sift through the 12 problems, find the really quick ones. You get 2 or 3 done in 10 minutes, and then try to focus on the other ones. There's a strategy involved to it. Improves your testing. It's definitely motivating. These kids, they just say, it's just fun. The contest I took them to was on a Saturday morning down at Brown University. It was the Saturday of the start of their vacation, and I had 6 kids that really wanted to go. That Monday on their vacation, I took another 6 kids to a competition at WPI, so that they didn't care that it was on their vacation. They still wanted to go to it. Again, the team building is a big aspect, and then again, the core programming skills. And then this was another quote from one of your students, right? Yeah. Do you want to talk about it?
Robert, the first quote is from, is actually the deputy leader for the New Zealand team, and he is one of the famous ones who didn't solve Paula's search for her perfect party dress. So he was one of the ACM team that was 11th in the world. So he's a very bright young man. And when I asked him what he would like to say about the benefit and so on of programming competitions, this was a quote from him. So much like woodwork, it's clearly best learned in a workshop rather than a classroom. And effectively what he's saying is that a lot of what happens in university, and because when he was going through there was nothing in high school, is not about the practice. And I think that I would reinforce that, because I'm always looking for sponsors, right? To try and get to the Olympiad costs us money, and there's no government money for it, and there's very small companies in New Zealand. So if anyone looks like they're even vaguely involved in IT, I start chatting to them. And coming back from a CSTA meeting last year, I was on a plane sitting beside somebody who was in a startup company in New Zealand, and in fact their company has sponsored us a small amount this year. But he said, and he wasn't old himself, he said, we can't get graduates who can code. And it's because the courses that you do in university actually don't just build muscle. And that's one of the ways that I kind of sell what I get kids to do. We have a summer camp between the New Zealand Programming Contest and between the Olympiad. We have a summer camp, and we just throw problem after problem after problem at them because we just want them to build muscle. And I think that it's hugely valuable for whoever eventually employs them. You can read all that. Just positive comments from other students. But the one from Robert I thought really nailed it, actually, is that is one of the major benefits, is that if you're involved in these contests, like I used to get my teams to practice before they went. I never took them cold, so I'd have lunch hour club and we'd all go and practice past problems and things like that. And they never got enough in the 3 or 4 months in which I did that to do really well at a contest, but they had a better idea of how to approach a problem than if we hadn't done that, building muscle. So now we're going to get into the, can you do this in your classroom? And we think that you can, and we're hoping that we can convince you. So the things that actually, I'll let Karen do this because she did this bit.
So there's different things, aspects. This I actually talked a lot to George Heinemann, who runs the WPI Worcester Polytech competition, about what went into his planning. He's been running a competition now for 5 years. So obviously you've got to first make sure this is if you were going to do kind of a regional competition where you would be inviting other schools to participate. Is make sure that people aren't on vacation. The biggest thing is setting up the problems, and I know Margot does this, so it is a big deal. So talk to other people, use the internet. He said he recycles problems or tweaks them a little bit. I know the ACSL, their problems every year are very similar, but they're different enough, and I'm always having different kids participate, so it doesn't really matter. You could invite people and have a problem party. What you want is also to have people try to solve the problems and see, read the problems and then try to solve them, see if there's any tweaking that needs. George said that he starts a full year before his contest trying to develop the problems. His biggest, I asked him what his biggest issue was in setting it up. The first year that he had the contest, we participated. There was probably like 14 teams, and I think 5 teams did not solve one problem. It was very demoralizing for them. So he had chosen problems that he thought were simple enough, but he was kind of thinking on a college level, that these weren't high school students that maybe didn't have too much programming experience. So you've got to give some really easy problems. And usually there's 1 or 2 that's just like, it's 2 lines of code, you've solved it. So you've got to put those in there so the kids feel like I'm on the scoreboard, I've at least solved one problem. And then you've always got to add in ones that maybe only one or two teams can actually get to. So usually at the contests, and I've been to contests where there's been problems that nobody solved. You got to put in enough that there's some good competition at the end, and there's one or two or three teams kind of fighting to get that last problem or last couple of problems. And they can, they could take a good hour or even 2 hours to solve the problem itself. Okay, so now we're going to talk about the PC Squared. So it's a downloadable program that you can install and actually run your own contest. It's somewhat simple. We've run into a few glitches ourselves because we were trying to get this running on my machine last night. So basically you have an admin, a judges, and then a scoreboard that you would run on your server machine. And then your teams would log in on different machines, and then you'd have a client running on those. So the admin is where you set up your team names, their passwords. You add all the problems, the input and output for them. You add in all your judges, what languages you're going to allow to be used, and then what form the executable takes and how you're going to run it. All right, so I'm going to let, or do you want us to go through this together?
We'll go through the slides.
Okay, all right, so yeah, we'll go through the slides first, and then we'll try to actually show you it running. So you download PC Squared, and again, I think I had the website there, but if you just Google PC Squared, so there's a, yep.
When you do it, never take the latest version. You take one back.
I made
So
that mistake,
we're talking version 8, and there is a version 9 there. Don't take it.
I made that mistake first. I took version 9, it didn't work. So version 8 is what we used. So there's a couple of .ini files you have to edit. So there's a site list, and that's where you would add in, the different sites. So what we did was just add in, we just call it My School. And then there's a site list.ini, then there's a pc2v8.ini, and in that, what you have to do is edit the IP address. So what I had to do on this was, get my IP address on the network here, and then just go in and put that in as the server. It was pretty simple. Then there's a couple of bat files that you have to run, the pc2server.bat, and then the pc2admin.bat, and that will actually start the admin running. So you just run it, runs through some Unix things, and then you would log in, and this is the screen that you'd get on the bottom here. So this is where you'd add in your accounts, the problems, the languages. And then the time is where you just actually start the program running. Okay, so here's where you're setting the contest length. And then you just start it, and there it goes. It's pretty simple. This is where you would add in a problem. So you would set up just the name of the problem, how long, if you want to set a time limit on it, how long you can run for, and then input and output. So if you want input from the keyboard, if you want input from a file, and then also output. This is where you would add in your languages. So it's got built-in C++, Java, I think, and I think you can add in any other languages you want. Okay, so this is on the team side. Right, so this is where they would actually choose the problem that they're going to solve. So if you have a list of problems, okay, I want to solve problem G, which language am I solving it with? And then you just choose your file, hit submit, and it gets sent to the admin. And then the judge would log in, so you'd have a judge log in on the server side. When a submission comes in, you just select it, it will show up on the list. So all the submitted problems will show up here with the team name. You just click it and you say execute, and then it will come back with either passed or not. Okay, so that's That's the PC squared. Well, let's run through the rest of the slides, and then we'll try to run the PC squared. So the other thing you need to consider is make sure that you have a really good network that's not going to fail with, however many teams you may have running on it. Or even if you're running it in your classroom, make sure that it's going to handle all the students submitting to you. Make sure you test it out before actually running it. I've been to a few contests where there's been glitches. One of my students mentioned the submission process was not the best. So it's, just make sure that everything's going to run smoothly the day of the contest. And then, make sure, especially if you're having outside people come, that you have your IT department kind of there, somebody there on hand, ready to jump in if there's any problems. Almost always the contests culminate with a pizza lunch or something, some horrible food that teenagers love. Make sure there's enough food for them, that they are teenagers and almost always boys, and they tend to eat a lot. In the morning, generally they serve breakfast or some sort of snack before they start the contest. Then, either at the end of the contest have lunch. I've also been to contests where the kids can go down and grab a bag lunch during the contest and eat while they're programming. How to notify schools about it would be to email all the schools in the area several months in advance. So just, George suggested the principals, if you don't know who the CS people are, even the math department or the technology department. Also word of mouth, possible CSTA chapters if you have a local chapter, and then continue with follow-up emails as you get closer and closer to the date. Usually there's some sort of an online registration, so it's really easy for the teachers to just come and register their teams. All right, so let's move to the PC squared and see if we can... All right, so here's the admin screen. Okay, yeah. So here's the folder with all the files that you'll get when you download PC squared. So it's a lot of batch files. And the INI files are here as well. So that's sitelist.ini. So basically, you could have several sites, but we just set up the My School as the single site, and then I have the other one. So the PC2.v8, which is where you have to edit the IP address. So that was just a matter of going in, and I just added in my IP address here and here. So that's all it is just editing those two lines. Oh yeah, right, and the site, change the site to say My School, or whatever you happen to have as the name of the site. So it's really just 4 lines that you're editing. We did that both on the server side as well as the team side. Even though I'm running them both on the same computer here, normally you'd have the teams running on different computers. So probably you just want to set up a single .ini file and then just copy and paste it into all of your different computers that would be running. All right, so this is what the administrator screen looks like. So you can add teams, judges, I guess administrators, and then the scoreboard. So I just added team 1, the site My School. Then we added in a problem, so we call it problem G. So let's just show you what it looks like. So you can add another one, just give whatever name. If you're going to have a standard input, the name of the file, and the same for an output file, you can give it an output file. So it's really easy to do. Languages, so we just added in C++, but you can also add in, they've got the basics here, Java, Pascal. So these are all the ones that kind of automatically built in. Yeah, I believe you can. Can you not? You can.
As long as you've got a copy of the compiler on your server, yes, yeah.
Right.
And you'll have to figure out this. You'll have to do this, fill in these fields, and we'll do it automatically for you. But it should work.
Right. Okay, so those are the three things we pretty much set up. And then you just go and you start the time. So we've actually got this contest running. It's actually stopped. It's 6. It was actually 6 hours. So this was from last night, when we were doing it last night. All right, so that's the admin. The team, again, looks pretty much like we showed you. So the only problem that we had added was Prop G. You choose your language, you choose your file. So, you know, you'd go to your CPP file and submit that. And then it goes to the judge. So the judges looks here. So team 1 actually submitted it twice. So you can say request run. Let's just see if this runs. I don't know if it will. Okay, so yeah, so we got compile errors on this. I thought we'd run into that problem, but that's pretty much how it would run, and we'll come back with either errors or hopefully that would run through. Okay, so that's pretty much how it runs. I've actually, this year I ran at the end of the school year, I ran a kind of impromptu one in my classroom, and all I did was I just had the kids email me. So I set them up in Teams, I gave them a set of problems, and I had them email me their source. And it was kind of the same thing, as fast as you can. It wasn't immediate, so I had to stop and run them, and I gave them the results the next day, but it kind of worked the same way. And it was really easy because I had a timestamp with email. Whichever team got it in first, would get the time. So it's an easy thing to do, even just using email, or if you have Blackboard or something like that where they can submit things. And the kids loved it. So are there any questions now? Yes?
Should I go from back here? I just wanted to throw in my 2 cents, both as a former contestant and then as a coach, and now I run a programming contest for Google. So I think these things are fantastic. I'm obviously a little biased, but I was I'm not at all biased. I was a physics major in undergrad, and a couple of years in, I saw a sign for one of these programming contests that was run by my university, and so I showed up and ended up getting a job at Google eventually. So and actually met my wife. So this all worked very well for me. In case any of you, PC Squared, it doesn't put on the smiliest of faces. You sort of look at all these menus and they look sort of intimidating. But I really think that this is something that could really get your kids inspired and really interested in computer science, and it really does. It teaches you how to code in a way that going to classes just can't. So I think it's a really fantastic experience, particularly these team things. There's two other, I guess I better put in a plug for my own contest, but there's a contest called Top Coder High School, where they have problems that are aimed in difficulty at high school students. And you just go to topcoder.com and look for the high school competition. It's an individual competition, and it's scheduled in the evenings at various times around the world. And I think that that's probably a very worthwhile thing for them to try as well. And if they try that, then they'll really want to get into the team stuff too. And the one that I run is called Google Code Jam, but it's more aimed at a university level. Though certainly we have had, in fact, we recently had our final online round, which is the qualifier for our World Finals. And I think a 16-year-old from Ukraine came in 6th. Wow. So certainly high school students can do this and can do extremely well. So I think this is a fantastic opportunity for your kids if you choose to get into it. Then it's PC Squared will take you half an hour to figure out, and from there you're off to the races. And I think it's a fantastic thing.
Great, thank you for that.
Code.google.com/codejam. If you just search for CoJam in Google, then yes, exactly. Just Google for CoJam.
I'm Pierre Bier, and I volunteer at the Stanford ProCo competition, programming competition for Bay Area high school students. And I just wanted to share a little bit with the group of what's happened. So we had our second yearly contest this spring, and we had about 150 kids come, so about 50 teams, so very representing all parts of the Bay Area. And there were a couple things that were different this year, that both of which worked really well. So we, instead of having just one echelon, we had basically novice and experienced. And the novice kids, in order to get into that, you had to be under 1 year of high school CS education. And I interviewed a bunch of them afterward, and they were just really gung-ho to be able to come in and compete, but not have to compete against third-year students. And so that part worked really well. The other thing that was very, very interesting and new this year is that the organizers, which is basically a group of sophomore computer science undergraduates at Stanford, they design and put on the whole competition. They had a game challenge, which is kind of getting into AI, where instead of students trying to solve just a problem thrown at them, the challenge in the afternoon was each team would write an automated game player. And so that what they chose for the game was the Connect 4. So you have this slots with an array of like 2 colored chips. You have to get 4 in a row. And so the way that worked was they gave everybody 2 hours of development time to just work on writing their game player, and they had practice. They had an expert that you could practice against during that time. And then when time was up, they just, you submitted your game code, and the games were all pitted against each other in a bubble up type of tournament. And it was fantastic. And I interviewed the kids coming out of that after they'd finished their development. This is before they've even, pitted them in the competition, but they were extremely enthusiastic about that type of a thing. It's open-ended. It's not right or wrong. It's basically who can think strategy, who can implement strategy, who understands looping systems and rule-based systems. It's really quite challenging, and yet even the novices felt that was well worth their time to be involved in that. So anyway, that's called ProCo. It's the programming competition at Stanford, and if there's anybody interested, I'll get you a link to the organizers.
Well, thank you for your comments. It is time for us to quit. And I think that some of you need to post on the blog. Can you make it quick? Because the next session is now in about 12 minutes.
Okay, one quick question. So lots of different contests. My name's Lauren, and I'm from up in Seattle. Which do you think is the most approachable for girls?
For girls. Good question.
Maybe it wasn't a quick question, but maybe that can be something we think about.
Yeah.
Blog post. Look at the blog on the website and see what we can find out about that. That's really good. Let's thank Margot and Karen and all the contributors.